Hello there and welcome. Today, let's talk about Mantis, a Backend-as-a-Service framework built in C++ to be very lightweight and pluggable. So first, before we talk about Mantis, let's first understand the different cloud service models that we do have today. So there are four major types: infrastructure as a service, platform as a service, backend as a service, and software as a service. So if you look at the infrastructure as a service, this actually provides the low-level part, which is networking, storage, servers, and virtualization. And then if you advance a bit on top of that, platform as a service actually adds on top of that some runtime, middleware, and OS that you can work with. Then if you don't want to go that low still, you can work with the backend as a service, and this provides data and some application that you can work with. And this mostly is to build your backend. So in this state, you don't have to worry so much about your front end because, you don't have to worry so much about your backend, since this will be provided to you, and then you can focus on your front end. And then lastly, one of the biggest category we have so much now is the software as a service, in which now you're provided some software to work with, and then you kind of you work on some minor tweaks here and there. So if you look at the backend as a service, some of the basic functionalities that is provided for you. At the bare minimum, you have the database to store your data. So this can be either SQL based or NoSQL based. Examples of databases here you can work with is MongoDB, you have PostgreSQL, you have MySQL, and many others. Also, you need to have some kind of file storage, and this file storage is basically to store file assets. This can be in terms of media content, can be in terms of files that you want to basically serve over the internet. And then additional to kind of provision all these things accessible through the internet, then you need to have some form of APIs. So these APIs will allow you to kind of access maybe some database records or even files which are already stored in our backend. And then now to control all of this, you need some kind of management, maybe through an admin panel, and all this of course will run on top of some kind of infrastructure. So additionally, other important things to have is some kind of integrations to third-party softwares and systems, and this can be good for things like you want to monitor your system using other tools like Grafana. You want to integrate with some push notification systems like you want to work with Firebase and much more. So some notable examples in this backend and service ecosystem include Firebase. I believe most of us have heard about Firebase or have worked with Firebase before. With Firebase, you're provided document-based storage, and then you have some kind of APIs to allow you to kind of access your data, as well as work with some files you've already stored maybe in your storage there. So a very robust tool and widely used, and very having a lot of integrations that you can work with. So this is owned by Google, so quite a bit constrained in terms of flexibility. And then alternative to Firebase, you have Upright. Upright is also kind of open source, but they also provide a cloud hosted version which you can kind of pay for. So it's quite simple, built on top of SQL based database, but providing a document based database. So they have some kind of things they have done on top of that. So very robust and very simple to work with. If you want a purely open source tool, then I'd suggest Supabase. Supabase is one of the best because it's actually built on top of a Postgres database. So everything is kind of built on top of that, and is very robust and very fast growing in the current ecosystem of backends we have. So you can also self-host your own Supabase instance and provide your own backend for your own applications. So although the three I've mentioned that are a bit heavy, so if you want something more lightweight, one of the tools I've talked about before is Pocketbase, which offers a lightweight backend, which is actually in a single file with a very beautiful database admin dashboard, and other kind of integrations you can work with. So all this provide you with the backend that you can work with, allowing you to focus on building your own front end and then seeing how to integrate it back into the backend you have. So today I want us to talk about Mantis, and Mantis is similar to the three tools you've talked about, the backend, but now this is actually integrated, focusing mostly on being very lightweight and pluggable. So still work in progress, built on top in C++, so it's can be compiled into a single file and provides you with a backend for both SQLite as a default database and with an option of PostgreSQL. We'll talk more about this in a second. So in terms of feature set that it's already provided for, so by default, APIs are auto-generated based on database schema you have, and then you have built-in authentication, basically using the basic authentication over username and a password, but some other features may be added later to support OAuth. And then by default, yes, as I said, we're working with SQLite, and to help improve on the issues about performance, then working with SQLite in write-ahead mode, wall mode. In Linux, currently we support also PostgreSQL. This allows you, of course, to use a PostgreSQL backend if you feel like scalability is an issue, and many other awesome features which have been added. So it's still work in progress, and today just want to give you a small preview of what you can be able to do with it so far. In terms of auto-generated docs, we have a link for it provided within the GitHub repo, and this will bring you this page, which gives you kind of some overview about what you can be able to do. So what you're going to be doing today is trying to get these pre-built binaries from the release page in the GitHub, running them locally to see how to get started with Mantis, and then later we'll try also to run it within a Linux environment to show you how to connect to PostgreSQL. And then in a future episode, we shall also work with building all this source from source to show you basically if you want to integrate with maybe a C++ backend, maybe code base or even C code base, maybe just basically how you can be able to build the whole thing into a DLL or a dynamic link library, and then you can see how to integrate with that. So to get started, what you shall first do is go back to our repo Mantis here, and then under our releases. So the latest version as per the time of this video was version 0.2.8, and we shall be fetching, for now let's fetch the Windows version. So all of it comes as a zipped package, so let's download that. It's around 4 MB maximum. Good. So with this folder, let's basically extract it to our particular directory where we are. That will take a second. Good. And if you open there, you'll find a single binary which is around 10 MB, around 11 MB in size. And to run this, so basically let's open our command prompt from this particular directory. So I will do that. So for us to run this, if you run the binary directly, just by doing Mantis app and you run it, so it will basically print out the version and exit. And once that is done, you'll realize that in the same directory we'll have two folders created. One is public, and this public is basically you can put here some HTML files, static files, and they'll be served automatically through the default endpoint. And then the data directory, this is where the database file is stored for SQLite specifically. So here you'll find the SQLite files. And then additionally, once we start storing file assets, things like images, into a database records, we shall have a new folder being created here called files, and each and every database table will have its own folder within that files that will store the different files that we have in our database. So to see the different options we can work with, so we can basically pass in help. So can pass in help to see the different options. So what is required for the default depends actually on what you want to do. So there are 4 major subcommands you can work with: admins, migrate, serve, and sync. So for admins, allows you to basically manage admin users within the database. So this is for adding a new admin user as well as maybe removing an existing user. This is important when you're setting up because you might want to first of all have a default admin to work with, and then later, once everything is set up, you can go in and add other users as admins as well. So for admin users, they will have access to the admin dashboard, as well as they will have full access to all the records within the database itself. For migrate, this is currently work in progress, not yet even implemented yet, but it's supposed to serve as a way to create a migration into and out of Mantis. For sync, similarly, it will be used for synchronizing between different nodes, but currently work in progress. So what shall be working most with today is serve, and this is where we shall be using to start a local server instance within Mantis itself, and through this server we shall be able to get the auto-generated API endpoints based on our database tables. So first and foremost, let's begin by creating our admin user that shall be using for authentication and all other kind of workflows going forward. To do that, let's do admins, and by default, if you just execute that, it will tell you that it expected you to pass in some data, either for adding or for removing particular admin users. So for our case, we want to do add, and by default we need to pass in the admin email. So I'll just do mantis.app, and then I'll be asked for the password, so you will key in the password and confirm. Once that's done, the admin account will be created, and once created, we can go now to use that the email provided here and the password you typed in here to log in as the admin user. So for us to start our server, we need to use the serve command, and the serve command has some other other arguments that you can pass in. One of them being you can provide the port you want this server to run on, you can provide the host you want it to run on, as well as the number of database connections you want to have. So you can have multiple connections in a pool that can allow you to have a lot of manage different connections at the same time. So for our case, I'll be providing some I'll be providing first this dev flag. I'll be setting it to allow me to see all the dev logs in our command prompt right now. So let me first begin by clearing my CMD terminal here. I'm on Windows. So let's begin here by doing dev. So if you just do dev and enter, you will see more robust logs being printed out, what's happening behind the scenes. And this basically shows you this is what you had seen earlier, logging out, logging the version you're working with. And then you'll see some SQL based setting up, truncating and setting the wall mode and checkpoint. And then by default, Mantis creates some few tables to work with. One is the admins table to manage all the admin accounts, and then you have the tables table, and this is used to manage all the table schemas that's managed by Mantis. You might have others that are not managed by Mantis, so you can still have separately. And then lastly, we also have the settings table, which will hold some data for different setting values you want to have. And so once this it starts up, so by default the routes being created are this is for admins. So admins will have an endpoint on /API/v1/admins, and this will allow us to manage admin accounts. So you can create admin accounts by the API as long as you are also an admin. So by default, we use get for getting all the list of all the admin accounts we have. This will be paginated, And then if you want to get a particular specific admin using the ID, this will be the API endpoint to work with. And then if you need to create a new admin, you can use the post. If you need to update, you can use the patch, and then of course the delete will be used for deleting a particular ID by ID. Additionally, for authentication purposes, we have this API endpoint /auth with password, allowing you to authenticate using admin email and password, and by default you'll be given a token which is only valid for about an hour. So all these parameters in terms of how long these tokens live will be adjusted from the settings once you have launched the first instance. We also get a generation of API endpoints for managing all the database tables. So this allows you to create tables on the fly, delete tables on the fly, update the tables, fetch a particular table, and much more. So you can work purely using the APIs once the server is started. All the other things are not important. So for us to start it up, you can basically do serve and allow access. So you'll have two endpoints. The first endpoint is it tells you that all the APIs will be under this URL / maybe the database table name, and then for the admin dashboard you have it under /admin. So if you had a static site within the public directory I showed you earlier, so back here you come back here to public. So if you had a static site here, then it will be served under the root endpoint here. So let's begin by looking at the admin dashboard, and then we shall look later at the APIs. So let's go to our browser and navigate to this. So we need to change this to localhost. So it'll be required now to log in, and for logging in we have to provide the credentials we passed in. Good. So once you log in, you'll be brought to this kind of interface. So on the left you have three options. You have the tables to show you all the tables you have in the database. Currently it's empty. And then you have the admins, and in the admins, if you go to it, it shows you actually the current admin you have. So you can even remove the current admin, and by default the user will be dropped as well from the database, so the token will be kind of invalidated. You can also add a new admin record from here by providing some data. Let's just add a dummy one. There's a back there anyway, but the new admin account is created, and as well you can drop it from here, and that's gone. So also under settings, this is where you can set the project name. This will be used later. Currently it's not being used, and then the current version you're working with. Also, this is the base URL for our particular instance. This will be used later, currently not being used. This is the session timeout for normal users, and then is the session timeout for admin accounts. All this can be configured from this point, and it will be saved and used for subsequent authentication. Then I think the rest, if you need to access documentation, there's a link directly here. So if you click on it, you should open a new tab for the docs. So the docs are also a work in progress, so not everything is kind of working 100%. Now back to our tables. So if you need to add a new database table, we can just click here on create tables, and kind of borrowed some of these concepts from Pocketbase, in that we have 3 table types. So you can have a base table, and a base table basically adds the ID, the created and updated fields into your table automatically. And then you have the authentication type, and for authentication type it adds email, password fields, as well as the name, the email and the password fields into your table. All these are managed by the system, so no need to kind of edit them. So you can additionally add other columns from this point. So let's first begin by creating a normal table. Let's give it test, and let's add a few columns. So let's name of column this column 1. So you need to provide the column type. For a case, I'll do string. If it's primary key is unique, if it's required, all these parameters you can set them here. I can add another column and do column 2. So let's go with maybe an integer 32. Now we'll do it's required. Let me add the last column, and maybe I will do column 3. Now let's go with maybe file or even files. Let's do a file. I'll do it's required, and then I'll create the table. So once you do that, the table called test is added to your SQLite database, and then you can now manage the records within the table by clicking on it. And here is where you are now allowed to add records to it. So if you do add record here, it will ask you for column 1. We can just do dummy value, and then for column 2, this was actually int 32, so you can't type in a string, so you have to provide an integer. For column 3, it's file based, so you need to kind of get a file, and then you can do create the record. That's created. So by default, the ID is auto-generated, as well as the database created and updated timestamps. So these are the data we have provided for column 1, column 2, and the image. So if you still click on this, you can see the record here, and you can be able to update it from this point. So maybe we can change that to 67. And then for a file, we can maybe pick a different file, and you can do save, and that's actually updated here. So to access this kind of record now from outside Mantis itself, maybe you want to access it through the API. So there is the API docs on the top here. So if you click on it, it should open this page, and this basically tells you that for you to list all the API records, you need to do a get request to the /API/v1/test, and test is our database table name that we are working with at the moment. You also need to provide a token, a bearer token. So this token, of course, you get it through the authentication endpoint. So for a case, either using the admin or any table that has the authentication auth type here. So you need to provide the column 1, column 2, and column 3 data. So basically just shows you some samples, and by default all the records are paginated. So you might provide your own data in terms of how you want them to be paginated. What should be the page size, how many records should you return, and then you can also skip it and set it that pagination should not be done at all. So it's up to you to kind of provide them using query parameters. So for getting a particular record, you can now pass in the ID if you know the ID. For creating a new record, you also have to do a post request and much more. And same for patching, for updating, as well as deleting. So this basically just shows you the APIs that you need to kind of call for you to be able to work with to access the database through the API. Now, apart from the API docs, you also have the config menu here, and this allows you to update the table itself. So for a case, you might need to add, maybe you want to add another column that was not considered earlier. We can do create a new column. It's added down here, so we need to do column new. So let's do it's optional. Let's even do it as a boolean. Once we are satisfied with it, we can basically do save schema. So if you save your schema, you notice now that we have a column new added at the end here, and by default it comes back as false because it's a boolean type and we have not set it out. So we can update it to true, save the changes, and that's now set to true. So if we go back also to our config here, there's a new tab. There's a tab here called access rules. So if you click on that, this opens up this part, and this shows you ways you can be able to set rules for people to access the different parts. So heavily borrowed from how Pocket-Based handles access. So for a case, you need to provide also the list rule for accessing the list endpoint, the get rule for accessing the get endpoint, add for creating a record, updating for updating the record, as well as delete. So all these rules need to be provided. By default, if it's empty, like right now, there is no rule provided. It basically means that you need to be an admin for you to access these records. So let's test it out. So I will copy this endpoint to a new tab here. So let's move this to the API. So this is for listing of the database record. So if you try and get it, it should throw an error that an admin authentication is required for you to access this resource. For you to make it public, so if you come back here to your config, you need to set this list rule to be public. And a very quick method is just setting here to true and save it. So if we save that and reload this page, good. So you now get the data we have. So this is the image that you are showing right now, as well as the data, and of course everything is paginated. So we have 100 records per page. Currently we only have one record here. So for how to set these rules, think of them as basically expressions that need to be evaluated to true for the user to access some of these fields. And by default, you have access to an authentication object which provides you with the current user's data. That's the ID, the name, as well as all the fields that pertains to the particular user who is kind of logging in, as well as the database table they are part of. Additionally, you also have access to the request data. So anything to do with the request body, request metadata, and much more is also provided. So you can use all that kind of data for you to make a decision on if the user should have access or not. So an example is you can limit whoever is creating. Like if you want to add, I can set it to admin only by setting it as blank that way. Another way, I can basically say authentication.table. I will do it to admin tables only. So by default, the admin is having 2 underscores that way. So this basically means for you to create a new record in this table, the authenticated user should be authenticated on a database table which is admins. So if they are authenticated in any other table, then they will not be able to add in the record here. So I can save that. Good. So can reload this. So if you go back to our terminal, so you can basically see all this is actually being logged out. So everything which is being done on the server itself is being logged out, and this can actually be piped out into a file if needed. So that's basically how the admin dashboard works. And as I've shown you, you can still work using the API directly without having to use the admin itself. So for the API, let me get Postman. So this is my Postman collection. So we begin by authenticating using the admin credentials. So this is what we had provided earlier: the email, and the password. So under the body, providing it as a JSON body, and we are calling the API /v1/admins, and then this is the endpoint for authentication. So if you send this request, the response gives you a token as well as the user details. So for a case, the email you provided, the admin ID for the particular user, and basically the timestamps for creation and updating it. So if you need now to authenticate to provide to do any other thing, maybe if you want to create a new database table, so using the API, we can come here and first under authorization we shall go with bearer token, and we need to provide the token here, and then under body, for you to create a database table similar to what we had done through the API, through the admin dashboard itself. So we need to provide the database table type. For a case, we can do auth, provide a database table name, and then you can also provide a list of fields that should be included. And for every field, the requirement is you need to provide at least the name and the type. So you can do an avatar and say maybe the avatar is of type file. So this will allow you to upload a single file. So if you want multiple files, the type here should be files in plural. And then other optional parameters include things like required, primary key, just as you saw them in the admin dashboard itself. So if you send this request now, let's just do send. So the response will be the full schema for the particular table created, which includes the unique ID for this table, the name, the timestamp for created and updated, and then the schema itself, which provides the rule for you to access these, the rules for accessing and updating and editing records in this particular created table, and then a list of fields, so including the default one like the ID for the particular table, the created, updated for timestamps, and then email for, because it's an authentication table, then we have email and password added in as well as some checks to ensure that actually is a valid password. A name also is added. So for this particular one, avatar is what we were adding in, an avatar, and then the age. So this table is now created in our database, and if you switch back to our admin dashboard here, and we can refresh by hitting this refresh button in our tables page, and we now have this users table. So if you click on it, it's actually empty here. So if you go back to Postman, you can maybe create a new record by coming here to create a new user record, and in here, first and foremost, you need to provide the bearer token for you to update it. So let's give it what we had gotten early, and then under the body, because we want to provide a file, then you have to send it as a form data. But if there was no file to be uploaded here, you can send it as a JSON body. So either will work. So for a case, an age of 23, email of that, a password of that, the name is that. So we can change the file itself and provide maybe that, my own picture as avatar, and then we can send this request. So as you can see, we have the response of the file name is kind of made to be unique. That way you can upload the same file multiple times, and all this data is actually updated. So if you switch back to admin dashboard and reload this particular page, you should see everything already set. So by default, the password is set here to empty, because in our response we kind of filter it out, so it comes back as empty. So back in Postman, you can see now how to create the user record. So we can list users. I don't think we need to, because we made it public, so I can remove this token from this point and basically just do a get request. Oh, sorry, this is the user's endpoint. So you see, it basically tells you now that admin authentication is required to access this resource. And for a case, we need to set it such that anyone authenticated maybe under the users table should be able to authenticate. So to do that, let's duplicate this tab, and I will basically do here users authentication, and then the table you want to authenticate users what we just added. I believe we created the user role under test@user.com, so let me just get that email and I will take it here. So we are authenticating to our users table, and we are using the email and the password in the body here. So if you send this request, we get a new token, and let me just copy this token. Let's begin by going to jwt.io. So basically to show you, so each token will have, of course, when it expires and when it was created, and then next has the unique user ID for the particular user, and then the particular table that it belongs to. So if we bring the original token we had for the admin user, see the difference now is that the table for this user is admins. So this is actually used when you're doing validation for the particular user, and that's why we add it in this particular fashion. So the particular secret key is actually if you look at the source code itself, it provides a default secret key, which you can actually override by providing an environmental variable for the same. So that all that is actually captured within the docs itself. So if you go back to Postman, so we have our particular token here, and I want us to use it now to list users. So if you come here to list users, let's put our token here, and then let's send the request. So by default, it still tells you that admin authentication is required, because how it's currently set, only admins can kind of list this record. So if you come back to config, we come to access rules, and because it's empty, so let's do out.table. You can do here users. Let's save it. Now let's send this request again. Good. You basically see now we are now able to get records back, because you are now authenticated as a normal user. Another way to test it out is we can do anyone who's authenticated should be able to list this record. So I can basically set if the particular ID for the authenticated user is not equal to empty. So we can save this rule, and then I can come back here and I can send this request, so it still works. So if we remove the token itself here and send this, it'll be told access denied. So you basically have to provide, you need to be authenticated via any table for you to access this record currently. So there are many rules you can play with, and you can also chain them. So I can also do that. I can also make it public by just doing here all true. Save it, and then send this oh yeah, you know. So to make it public, you just set it to true. Good, that works. So that shows you how to basically work with the API, as well as how to work using the admin dashboard itself. Other things you can do, let me switch back to the main dashboard. So you've seen how to create all these tables from the dashboard as well as creating them from the API. So the same applies for updating the records. You can work from either side of things. Then so for PostgreSQL, let's try and set it up and see how to work with it. And for this particular case now, I'll be switching to Linux for me to show you how to connect to a PostgreSQL instance using Mantis. So I'll be using WSL. So what I want to do first is to launch my PG admin, because I have it set up. Also, I need to launch my Docker because I'm running PostgreSQL on my Docker container. So this is loading. So next, because you have seen how to work with this, so I'm not gonna be, I can stop this server right now, and just to show you, if you reload here, it should throw an error. Yeah, it cannot be able to fetch because it can't reach the server. Then let me switch to Ubuntu here. I can do that. So let's create a directory here. I can do let me increase the font so they can be legible a bit. For my PG, so I already have a PostgreSQL set up already, and currently, because I've been using it for testing, it has, just show you, this is very small. Good. So under admins, we already have an admin record created by the same procedure I showed you earlier. Under settings, I do believe we have some data. This is the default settings, so it's basically a very big JSON string. Under tables, we already have some data in this table. So if you load it, you'll see 3 tables: users, teachers, and students. And then for each of these tables, we also have some dummy data already populated in. So I'm not going to drop this table, maybe this database, we're going to work with it just to show you how to connect to it. So by my current configuration for this PostgreSQL instance is, so for you to connect, you need the database name. You also need the particular host name. Host name is basically where it's located. You also need the port, which is, it might be default, but for my case, I think it's 5433. Yes. So for you to connect, let's first begin by fetching Mantis for Linux. I'll switch back to my GitHub releases page. Here is for Linux. I will just copy link address, switch back to here. So let me get that compressed file. So if you check, we have downloaded this Mantis app. So I will unzip it here. I'll do Mantis app. So if you list, you now have Mantis app binary here. So let me just clear this page. So just to show you that it also runs using SQL. So I will do undo here Mantis app. As you can see, you can basically do serve, and you see it does exactly what you had seen from the Windows counterpart. So let's stop this, and then now before we do serve, we need to provide a connection string here. So let me just do have. So what we need to set one, we need to set the database we are working with. So by default, the default is actually SQLite, but you need to set it to PostgreSQL, and then we need to provide the connection string by providing these parameters. So a connection string is basically a string containing all this data: password, username, database name, host name, port name, all these details we need to have. So for us to do that, so let's begin by doing database. I'll do BSQL, and then I'll do connection, and then I will do serve. So we also do def. So if you run this, it will throw an error because there is no connection string provided. So we need to set that. So let's come back here. So we need to provide DB name, and I will do Mantis. We need to provide host, and I will do 127.0.0.1. We want to provide port, and I'll do 54.3, and then user is Postgres, password so Postgres. Good. So with these credentials provided, we are setting the database name that you want to connect to, the host where it's located at. You might ignore host if you're running within the same instance. So for my testing, I was working with Windows to Linux and Linux to Windows, and I had to provide this explicitly. For port, I'm running on Docker, and I have a number of instances for PostgreSQL. So mine is this. For this instance, I'm working with 54.3, and then of course you need to provide the credentials for PostgreSQL, so the username and the password, and that's all you need to do. So once you do that, remember I'd shown you some of the database tables we have. One is students, which is, you can see 8 APIs being created on this point. So students is an authentication type table, so you'll also have this authenticated password. You have teachers, and teachers is not an auth table, so you only have the 5 of them, 5 endpoints. For users, similar to what we had initially for SQLite, it's an authentication type, so you'll have the out with password endpoint created as well. And then for administrative purposes, you have the admins and the tables. So basically similar functionality. And just to show that this actually works, let me see if I can have these things side by side. Bring this here. So I think I also need the dashboard. So if I reload this, I should get an error that the authentication ID was not found, because the authentication token is still valid, but the particular user ID is wrong. So we may need to log out here, and then we can log in, and we'll get now a new token we can work with. So you can see you have the 3 tables, students, with their respective data. So the files are missing here because they were created on a different folder, so that folder contains those files. So the files are saved locally from the folder which was set. So you have command line arguments to setting which folder will be used, and that's actually so if you go back up, so for you to set the particular folder, you need to set the data directory. This is where we store the SQLite files, as well as the file, as well as any other assets that's saved in the database itself. So for a particular case, we are using the default one, which is basically same directory as where we run our Mantis app, our Mantis binary in this sense. Yeah. So let's create a new table here. We'll do test pg. Yes, it's a base table. I just do create, and that's created. So from test pg, will add a new record. There's no fields added, so by default we just have these three fields: id, created and updated, create the record, and we have the three. So if you go back to our pg admin, let's refresh the tables we have here. Refresh this, and we should have this test pg added, and we can visualize the data. So we should have this data, which is identical. Yeah. So similar functionality, no discrepancies per se. So it will basically allow you to switch the backend as needed. If you're switching maybe from SQLite to PostgreSQL, once you've transferred all your table records, for the files, you just copy the folders for the particular files over, and you'll be good to go. So that's basically an overview of Mantis, a very lightweight backend. So if I run a quick bench test, I do believe I have some scripts. Let me go back to Ubuntu. Good. So I can test let's do this test Mantis. So in this script, I'm providing the authentication token, and then basically I'm using the Apache Bench to send 100,000 requests with 1,000 connection, and then I'm basically logging all that different requests into a file. And for a case, I'm basically trying to hit this endpoint. So I'm listing out all those. I'm listing out all the data in this particular endpoint. So I can set this endpoint to public. So if I come here to config, no, I think I need the users table, so I can come back to users, do config, access roles, and I can just set this to true, and this will I think I have a bug somewhere. I'll have to check on it. Interesting. Okay, I'll check on that later. So for now, I have to provide authentication token. So I can switch back to users table here. And if I send this request, I get a new token. I can copy this token. So I can use nano to do test. I can do token is so let's run this bench test by doing think we are getting errors. Check here. So for some particular reasons, I believe we are hitting some issue. So it can't get the endpoint. So I'm not sure exactly why we're getting the earlier errors. I think it's still the same. Interesting. So we have so we have the health endpoint. So let me try and see if we can test with the health endpoint, because this original test was written for a different setup. Good. So for 100,000 requests with 1,000 concurrent connection, I think we are doing about around the 3,000 requests per second. It's not really impressive. It's not also bad. I think there are some things that is still adding a bottleneck to all this setup. One being the authorization module. So if you run the same benchmark against a table that has some of these guardrails already set up, you might see way lower requests per second. I think from yesterday's test using SQLite, we were hitting around 7,000, 8,000 requests per second. And that's actually a setup that requires you to be fully authenticated. So I think with PostgreSQL, you should be getting much better responses in terms of requests per minute or per second, sorry. In that, of course, it might, not an assurity that it will, but it might. So with that, I hope you found Mantis interesting. So have a test, see how it works, and if you experience any issues, feel free to create a new issue within the GitHub repo here. Also for the particular docs, so the docs are located here as shown earlier under the docs.mantis.dev, and these docs are a bit auto-generated from the source code itself, so it might be a bit more verbose. So there are some very small arrows to expand each section on the left, which are not really visible, but can allow you to go through each and every step, seeing the command line usage you can work with and different options you have. showing some examples you can work with, explain to you different REST APIs and how to get access rules and how to kind of understand them. So some of this documentation might be a bit outdated, a bit, not so much. So because there are some future changes which were done recently, maybe they are not really reflected here yet, but they should be for most part still correct. So in our next video, we'll do an overview on how to embed Mantis. And embedding basically is, if you have a C++ code base and you want to use it as a library, you can basically embed. And this will, one of the requirements, of course, is to build Mantis from source. So we'll go through all that flow and show you exactly how to build it from source. So by default, Mantis is a library itself, and then the Mantis app is the command line part of it that allows you to run it from the command line. Yeah. So with that, thank you for sticking through the end. I hope to see you testing it out, and if you have ideas on how you can improve the project, if you have some patches you want to send in, feel free to do that, and let's build this idea together and make it way better. Of interest also is to get more people to test it out on different platforms. The next platform of interest is, of course, on ARM boards. Currently we don't have any ARM build being generated yet, but it will be of interest to test it out on a Raspberry Pi and even other boards which have lower compute power, basically to see how it performs, and then we can see how to optimize it. So there are many things we need to optimize and build around, but first let's test it out, and then let me know your feedback. So send in, if you have an issue you want us to discuss, you can create an issue and let's discuss it from that point. So with that, thank you for sticking through the end, and I will see you in the next video. Bye.